Hi there, my name is John Dunnick. Welcome to the Lunchtime Tutorials where we solve a problem using COMSOL multiphysics. Now, in this particular tutorial, we'll be capitalizing on one of COMSOL's strengths in that anywhere in COMSOL you can type a number, you can type an equation, which means that for the viscosity, rather than just typing in a temperature-dependent viscosity or just a number, we can use that to simulate a gate valve, and you'll see that later in the tutorial. So this tutorial is looking at a gate valve downstream of a wide joint in a typical pipe. All right, and the question is, what's the flow rate as the gate closes? And then we have a small feeder stream that's feeding in about midstream, upstream of the Y, and as the gate closes, where does that stream go? So let's talk about the problem itself. We've got velocity coming in the main end at half a meter per second. We've got this feeder stream coming in at a quarter meter per second. The gate valve itself, and then pressure equals 0 on the outside. Now this is a standard 4.5 inch, 4.5 inch steel pipe, and then we've got this valve. Okay, the valve itself's got a 5-inch total travel, and it's a true valve in that it seats a little bit in a recess inside the valve itself. So when it's fully closed, obviously there's no flow. But when it is open, it has to get to about 9% open before it's actually skimming the inside of the pipe. When it's 50% open, it's at the midline. When it's 91% open, it's skimming the top part of the pipe. Now let's talk about where we're going to go with this particular simulation. We're going to do this in 2 steps. First, we're going to set up and solve the flow problem as if the gate valve wasn't there. I mean, geometrically it's there, but we're not going to handle the gate until the second step. So the procedure is going to be choose a physics, in this case Navier-Stokes. We'll import the geometry sequence. We'll choose materials, in this case water. We'll set the inlet and outlet boundary conditions, mesh it. We're going to run into a little interesting problem with the mesh. We'll clean that up, we'll remesh it, and then solve it. So I'm going to do File, New. All right, this is a 3D problem, so I'll choose 3D. Hit Next. I'll go into Fluid Flow, Single Phase, Laminar. Next. And then I'll choose Stationary in this particular case and do the Finish flag. Now, these units happen not to be in meters, they happen to be in inches, so I'll change it to inches. And then before I actually bring the geometry in, the geometry needs a few parameters. So let's open that up. So I'm going to right-click on Global Definitions. I'll choose Parameters. Now, I could type these in, but I've already typed them in, so I'm just going to read them in from a file. So Load from File. And here's the gate valve parameters. Double click on it, and as you can see, it are things like percent open, where's the position of the bottom of the gate when it's fully closed, what's the travel of the gate, and here are the ones that we need for the geometry, the ID, the OD, and the flange OD. These are all parameters that are used by the sequence. So let's, now that we've got the parameters, let's bring in the sequence. Right-click on Geometry, and I'm going to import the sequence from File. So I'll choose that. I'll bring in the gate valve geometry sequence, and what it's doing is looking at another COMSOL file where I put all this stuff in. And these are all these various things. These are all built in COMSOL. Let me build this entire thing, so I'll build all. And what I see is a nice gate valve built in COMSOL. Let me clean up a little bit right here. I'll close up. I'll go into definitions, open that up, go to view, and let me turn off the grid. It just cleans up the view. It looks a little bit better that way. And then I'll switch to wireframe, a little bit easier to see inside, and it'll make it a little bit more convenient, particularly when choosing boundary conditions. So now I've got my geometry. Let's go to the materials. So let's right-click on Materials. I'll open up the Material browser. I could also specify materials if I want. I'll go to the built-in one. That's what ships with base COMSOL. And most of this, valve structure is made out of steel. So I'm going to go down and pick the most common material, steel, ANSI 4340. Right-click, add it to the model, and it puts it everywhere. Okay, now it's complaining about the viscosity. Well, that's okay. Just hold that for a minute. I'm going to open the material browser again up in this tab, and let's put in the water itself. So I'll choose water, right-click, and add it to the model. It says, oh, wait a minute, everything's made out of steel. Where's this water stuff? Well, it's there. Let's see, not there, that's steel. There, and then in the gate valve, the gate itself right there, and the other gate itself right there, and then I need to get the feeder line. So let's zoom in a little bit, make that a little bit easier to see it. There it is. Now I know I'm going to need this later, so I'm going to create a name selection. So I'll pick create selection. Let's call that fluid. Okay, so I made that fluid, and then I'm all set. Now it's still complaining about steel. Why? Because the laminar flow, when I highlight this, it's calculating flow everywhere, including in the steel. Well, we don't want that. I don't want it in all the domains. I just want it in the name selection, the fluid. So by making that name selection, I don't have to go pick it again. Okay, now let's zoom extents. Okay, and so now I'm all set up. Now I'm going to put the boundary conditions in. So to add boundary conditions, I'm going to right-click on the physics, right-click on laminar flow. I'll choose symmetry boundary conditions, and then again, I'll pick the ones that are the proper ones for the symmetry on this problem. Right there, right there, right there. Okay, let me zoom in because I know the gate is a little bit easier to see if I get in really close. That one right there, that one right there, that one right there, and then I also need the feeder, so let me zoom in on the feeder right over there, and that one right there, and now I have all of the symmetry boundary conditions set. Okay, let's put some inlets in. So right click on laminar flow, I'll choose an inlet. That one right there, this is coming in at 0.5 meters per second. I could have made that a pressure or whatever. I'm going to leave it as velocity. And then I need the inlet to the actual feeder. So again, I will zoom in, make it a little bit easier to see. Right click on the physics, laminar flow, choose another inlet. And then I'll choose the feeder inlet right there. That's moving at 0.25 meters per second. All right, and now I've got flow going in, no flow going out, so I'm violating conservation of mass. Don't want to do that. Right click on laminar flow, choose outlet, and then pick that guy and that guy. I'll leave it pressure 0. That's just fine. So we're doing gauge pressure right here. All right, so I now have my geometry spec, I have my materials spec, I have my physics spec, in this case laminar flow. Let's do the mesh. So let me close this guy up and come back into the model, and now go to the mesh. So I'm going to right click on mesh, choose a free tetrahedral mesh, and I know that I want to specially mesh the feeder line and the gate valve with something small. So let's just pick those particular ones. So I'm going to zoom in again on the feeder. All right, so I'll pick this one right here, and then I'll go into the gate. Again, zoom in right here. Okay, that one and that one. Now I've got the gate, and in these particular ones, I want to really give it a nice fine size. I'm going to calibrate for fluid dynamics. That gives you an even finer mesh than normal. And then I will do just plain old fine, and then see what this looks like. So if I build it and solve it, it looks a little bit coarse right there. Let me look at what the feeder itself is. I'll zoom in on the feeder right here. Looks okay for the feeder. So let me change the mesh size for the gate valve. Right click, I'll add another size. And then on this one, I'm just going to do it on the feeder right there. Not the feeder, on the gate valve. My apologies. I'll again calibrate for fluid dynamics. And let's make this one extra fine and build that. So now I've got fine here, extra fine there. I'll zoom in, and I know that's going to look just fine. That's just fine. Okay, so the rest of it I can just mesh the remaining as it would like, build that. And I'm going to get an error. Actually, I'm going to get a warning. This one actually is just fine. But it's complaining about how narrow this V is right here, and perhaps right here. So I'm going to show, we could ignore this, to tell you the truth. It's a warning. It just went just fine. But in this case, I want to show you a powerful thing that is in COMSOL, and that is virtual geometry operations. So let me clean that up. So I'm going to right-click on geometry. I'm going to go down here to virtual operations, and I'm going to form a composite face. Okay, now in this case, what I'm going to do is carefully pick the inside of the pipe, the other inside of the pipe. Did I get the inside? I think so. This inside of the pipe, and this inside of the pipe. Let me make sure I've got the insides here. The pipe's not all that thick, so it's fairly easy to get the wrong surfaces. Looks like I got an inside on everything. That's great. All right, now let me go do the same thing on the outside. So I'm going to right-click on geometry, and then I do another virtual operation, and then form another composite face. And I'm going to do this one on the outside. So that's that one, this one right here, this one right here, and this one right here. So again, I'm just making sure I got the right surfaces. That looks good. So let's build it. And it's going to look like nothing happened. Actually, in geometry, nothing has happened. But we've changed our interpretation of that in the physics and mesh. Notice those lines that were causing the mesher to have problem are now gone. So the surface is now a clean, smooth surface. Let me build this mesh, and then what you'll find is you still get the right shape, but the mesh no longer has that problem of these very narrow regions right here. So you've given the mesh an ability to mesh this in a smoother manner. This is a great tool for this type of problem. Okay? So we now have the mesh all set up. The only thing we need to do is a study. So I'm going to, I could right-click on study and hit compute and I'd be done. But I want an answer really quick. So I'm going to do a little quick thing. Right-click on study. I'm going to show the default solver. In other words, please build the solver, but don't run it. Now I'm going to go into that solver that it built and I'm going to do one thing. It defaults to an iterative solver, which is a fine solver. It's very memory efficient. I know this will fit in my computer, so I'm going to enable the direct solver. That's a faster solver in this case, but it cost me memory. So now I've got the direct solver. I'm going to right-click on study and hit compute. And indeed, I've got a nice flow right there. And if I look at the messages, indeed, 24 seconds, even faster than I remembered. So let's go in, clean up some of this output. So I'll do a quick plane. I'll do an XY plane in this case. Based on coordinates, I'll just bring it in just a little bit. So let's do a negative 0.05, about a 1/16 of an inch in, and then plot that. And then what we see is the flow going straight on in. No surprise, the gate valve's not closed. We haven't done anything about the gate valve. I'll get this feeder stream going in. Let's see where the feeder stream goes. I'm going to right-click on velocity, and I'll give it a streamline plot. A number of ways we can do streamlines, but the default is tell me a surface where they're starting from. So I'll come in at the feeder valve right there. And I happen to know this looks better in black, so let's change the color to black. Sometimes it looks better in other colors. All right, and then zoom away. And then you can see the feeder stream coming in. It's like I put a little ink line in there. And you can see that it's coming in midstream, but because of the Y, it goes over about, I don't know, about 70% down, something like that. All right. So with that, let me move on to the next part of this tutorial.